For this problem, I'm going to show that one matrix is the inverse of another matrix. So I have the matrix A given and also the matrix B, and I want to show that B is the inverse of A. In order to show that, I need to multiply A times B together and get the identity matrix, and I also need to show that B times A is also equal to the identity matrix. So I have two multiplication problems to do. I'm going to do this problem in red because it's really just a check. I have a matrix and its inverse given. I'm just showing that they are actually inverses of each other. So first, let's multiply A times B. When we do that, I will use the matrices above to help me. And we're going to get a 3 by 3 matrix, and we're going to start in row 1 of A and in column 1 of B. We have 1 times negative 3, which is negative 3, plus 2 times 7, which is 14, plus 2 times negative 5, which is minus 10. Now we'll move down to row 2, column 1. We have 2 times negative 3, which is negative 6, plus 3 times 7, which is 21, plus 3 times negative 5, which is minus 15. Going down to row 3, column 1, we have 1 times negative 3, which is negative 3, plus negative 1 times 7, which is negative 7, plus negative 2 times negative 5, which is positive 10. Now we'll move on to row 1, column 2. So we have 1 times 2, and I'm actually going to put it the middle row, the middle column actually in a different color so it doesn't run together. So row 1, column 2. 1 times 2 is 2, plus 2 times negative 4 is minus 8, plus 3 times 2 is 6. Next I have 2 times 2 is 4, plus 3 times negative 4 is negative 12. I'm moving across row 2 and down column 2. I have 3 times 3, which is plus 9. Finally, row 3, column 2. I have 1 times 2, which is 2, plus negative 1 times negative 4 is 4, plus negative 2 times 3 is negative 6. And then I'll move back to red for my last column. So I'm going to start at row 1, column 3. I have 1 times 0 is 0, plus 1 times 2 is 2, plus 2 times negative 1 is minus 2. Row 2 times column 3. 2 times 0 is 0, plus 3 times 1 is 3, plus 3 times negative 1 is minus 3. And then we have row 3, column 3. 1 times 0 is 0, plus negative 1 times 1 is minus 1, plus negative 2 times negative 1 is plus 2. And then I'll simplify this matrix to show that it is the identity matrix. Negative 3 plus 14 minus 10 gives me 1. Negative 6 plus 21 minus 15 gives me 0. Negative 3 minus 7 plus 10 is 0. Going down the middle column in blue, I have 2 minus 8 plus 6 is 0. 4 minus 12 plus 9 is 1. 2 plus 4 minus 6 is 0. The third column, 0 plus 2 minus 2 is 0. 0 plus 3 minus 3 is also 0. 0 minus 1 plus 2 is 1. So I've shown that if I multiply A times B, I do get the identity matrix. But I also have to show that B times A is also the identity matrix. So in some cases it's easier to rewrite them in the order that we're going to see them. So in order to multiply B times A, I'm going to do that on another sheet of paper. And so when we check B times A, it's nice to write the first matrix first, in this case B, and the second matrix second, A. So B times A will also show is equal to the identity matrix. So let's multiply that out. Negative 3 times 1 is negative 3, plus 2 times 2 is 4, plus 0 times 1 is 0. Row 2 times column 1, 7 times 1 is 7, plus negative 4 times 2 is negative 8, plus 1 times 1 is 1. Row 3, column 1, negative 5 times 1 is negative 5, plus 3 times 2 is 6, plus negative 1 times 1 is minus 1. Now we have row 1, column 2. Negative 3 times 2 is negative 6, plus 2 times 3 is 6, plus 0 times negative 1 is 0. Row 2, column 2. 7 times 2 is 14, plus negative 4 times 3 is minus 12, plus 1 times negative 1 is minus 1. Row 3, column 2. Negative 5 times 2 is negative 10, plus 3 times 3 is 9, plus negative 1 times negative 1 is 1. Row 1 times column 3. Negative 3 times 2 is negative 6, plus 2 times 3 is 6, plus 0 times negative 2 is 0. Row 2 times column 3. 7 times 2 is 14, plus negative 4 times 3 is minus 12, plus 1 times negative 2 is minus 2. Now row 3 times column 3, I have negative 5 times 2 is negative 10, plus 3 times 3 is 9, plus negative 1 times negative 2 is plus 2. And when we simplify this, we get the 3 by 3 matrix. Negative 3 plus 4 plus 0 is 1. 7 minus 8 plus 1 is 0. Negative 5 plus 6 minus 1 is 0. Negative 6 plus 6 plus 0 is 0. 14 minus 12 minus 1 is 1. Negative 10 plus 9 plus 1 is 0. Negative 6 plus 6 plus 0 is 0. 14 minus 12 minus 2 is 0. And negative 10 plus 9 plus 2 is 1. So not only have we shown that A times B is the identity matrix, but also B times A is the identity matrix, so B is the inverse of A.